Have you ever looked up at the night sky and wondered if there are other worlds out there, orbiting stars far beyond our solar system? Could there be planets teeming with life, or even civilizations similar to our own? While it might sound like the stuff of science fiction, astronomers have made one of the most groundbreaking discoveries of our time: exoplanets. These are planets that orbit stars other than our Sun, and they come in an incredible variety, from gas giants that make Jupiter look small to rocky planets that could be Earth's distant cousins. Exoplanets are transforming how we see the universe and our place in it. In today's video, we'll dive into the fascinating story of how these alien worlds, why they matter so much. For millennia, humans have gazed at the stars, weaving myths and legends about the twinkling lights in the night sky. In ancient Greece, philosophers such as Epicurus and Democritus suggested that the universe was composed of an infinite number of atoms, forming countless worlds scattered across the vast cosmic ocean. Although they had no means to prove their claims, their curiosity laid the foundations for one of humanity's greatest questions. Are we alone in the universe? As the centuries passed, we charted more accurate maps of the heavens, discovered that our Sun is but one star among billions in the Milky Way, and eventually came to realize that there are billions of galaxies beyond our own. This immense cosmic expanse prompted us to wonder, surely there must be other planets orbiting those countless stars. Mustn't there? Yet this question remained purely speculative until recent decades. Let's delve into how we finally confirmed the existence of planets around other stars. You might be surprised to learn that the first exoplanets were not found orbiting a star like our Sun. In fact, they were discovered orbiting a pulsar. A pulsar is the incredibly dense, rapidly spinning remnant of a massive star that has exploded in a supernova. Talk about an extreme environment. In 1992, astronomers Alexander Wolszczan and Dale Frail detected unusual variations in the pulses coming from a distant pulsar named PSRB 1257+12. These variations were so regular that they indicated the presence of at least 2 planets orbiting the pulsar. Discovering planets around a rapidly spinning stellar remnant was astonishing, as it was so vastly different from our own solar system. Nevertheless, it marked the first confirmed detection of exoplanets. This discovery gave astronomers a thrilling boost. If planets can form around a pulsar, what else might be possible out there? Suddenly, the search for exoplanets was well and truly underway. Just a few years later, in 1995, astronomers Michel Mayor and Didier Queloz made a discovery that forever changed our understanding of planetary systems. They identified a planet orbiting a Sun-like star called 51 Pegasi, located roughly 50 light-years away. This planet, named 51 Pegasi b, was discovered using a technique known as the radial velocity method, often referred to as the wobble method. Here's the basic idea. As a planet orbits a star, it exerts a small gravitational pull on the star, causing it to wobble slightly in space. By employing highly sensitive spectroscopy, astronomers can measure shifts in the star's light, similar to the Doppler effect in sound, but applied to light. If the spectrum of the star shows a periodic shift back and forth, it strongly suggests the presence of an orbiting planet. 51 Pegasi b surprised everyone because it is classified as a hot Jupiter, a gas giant larger than Jupiter but orbiting extremely close to its star. It completes an orbit in just 4.2 days. The discovery by Mayor and Queloz not only confirmed that exoplanets can orbit stars similar to the Sun, but also introduced us to planetary systems that are strikingly different from our own. Once astronomers confirmed the existence of exoplanets, the next major challenge became evident. How do we find more of them? Unlike stars, planets don't emit their own light. They're tiny, faint, and often obscured by the bright glare of their parent stars. As a result, astronomers needed to get creative, employing ingenious techniques to uncover these hidden worlds. Let's start with the radial velocity method, also known as the wobble method. Imagine a star as a heavyweight dancer and a planet as its smaller yet significant partner. As the planet orbits, it exerts a gravitational pull on the star, causing it to wobble slightly. Astronomers can detect this wobble by studying shifts in the star's light, similar to how you might hear the pitch of a siren change as it passes by. This method is particularly effective for identifying large planets close to their stars, such as the scorching hot Jupiters we mentioned earlier. Sometimes, however, planets reveal themselves in a different manner by transiting in front of their stars. This is known as the transit method, which involves looking for tiny dips in a star's brightness as a planet passes in front of it. It's akin to observing a light bulb dim slightly when a speck of dust crosses its beam. NASA's Kepler Space Telescope excelled at this technique, identifying thousands of planets by capturing these fleeting moments of cosmic shadow play. Now, if we wish to actually see an exoplanet, we turn to direct imaging. This method is akin to donning sunglasses to block out the glare of a flashlight so you can glimpse a nearby firefly. It is incredibly challenging, as stars can outshine their planets by millions of times. However, innovative tools such as coronagraphs are aiding astronomers in capturing snapshots of these elusive worlds. Another fascinating method is microlensing, which comes straight out of Einstein's playbook. When a star with a planet passes in front of a more distant star, the gravity of the closer star acts like a magnifying glass, bending the light from the background star. If timed just right, you can catch a glimpse of the planet accompanying the star. It's rather like spotting the shadow of a bird on a windy day, tricky and unpredictable, but immensely rewarding when successful. Together, these techniques have helped us discover over 5,000 exoplanets so far, and that number continues to climb. Each new discovery adds another piece to the puzzle of how planetary systems form and evolve, and the diversity we have uncovered is nothing short of astonishing. Exoplanets have turned out to be far more diverse than we ever imagined, and every new discovery seems more mind-blowing than the last. Astronomers are finding worlds that feel like they've leapt straight out of science fiction, but they're very real. Let's dive into some of the most extraordinary types of planets we've discovered so far. Let's start with the hot Jupiters. These gas giants orbit ridiculously close to their stars, where the heat is almost unimaginable. Think blistering temperatures, ferocious winds, and raging storms on a scale that makes hurricanes on Earth look like a gentle breeze. Picture a version of Jupiter so close to the Sun that its atmosphere is practically boiling away. That's what we're dealing with here. Then there are the super-Earths and mini-Neptunes. These are planets that fall in a size range we don't have in our solar system. Bigger than Earth, but smaller than Neptune. Some are rocky giants, others are wrapped in thick layers of gas and ice. What's really intriguing is that some super-Earths could be rocky havens, potentially straddling the line of habitability. It's enough to make you wonder if these could be homes to alien life or even future homes for us. Now, if you want extremes, you've got to hear about lava worlds. These planets are so close to their stars that their surfaces are literal seas of molten lava. Take Coro T7b, for example. It's basically a hellish landscape of glowing lava oceans, locked under perpetual, scorching daylight. It's beautiful in a terrifying kind of way. On the cooler side of things, we have the water worlds. Imagine planets entirely covered in vast, endless oceans. No land, just water as far as the eye can see, if you could even stand on the surface, that is. We haven't yet confirmed one with absolute certainty, but the very idea of an alien ocean planet is thrilling. Just imagine what could be lurking or swimming beneath those endless waves. And then there are the rogue planets. These are the loners of the galaxy, drifting through the darkness without a star to orbit. They're shrouded in perpetual night, moving silently through space like ghostly wanderers. We've only detected a few through microlensing, but they remain some of the most mysterious and intriguing worlds we've come across. The sheer diversity of these planets is mind-boggling. Each discovery challenges what we thought we knew about how planets form and evolve. These aren't just strange phenomena to catalogue. They're reminders of how vast and surprising the universe truly is. And if these incredible worlds are any indication, the cosmos has plenty more surprises waiting for us. One of the most exciting goals in exoplanet science is finding a planet like Earth. Specifically, astronomers are on the hunt for planets located in the habitable zone, the sweet spot around a star where liquid water could exist on the surface. Since water is essential for life as we know it, discovering a potentially habitable planet is a huge deal. And the good news, we've already found quite a few Earth-sized or slightly larger planets within the habitable zones of their stars. Take Kepler 186f, for example. It's about 10% larger than Earth and orbits in just the right zone of its star for liquid water to exist. Then there's the TRAPPIST-1 system, which is absolutely fascinating. It's got at least 7 Earth-sized planets, and several of them might be capable of supporting water. Imagine a star with 7 rocky worlds, all huddled close together, each just a bit larger or smaller than Earth. It's like something straight out of a sci-fi movie. But this search for another Earth isn't just about satisfying our curiosity. It's about tackling one of humanity's oldest and most profound questions. Are we alone in the universe? If life could emerge on one planet, surely it could happen again somewhere else. Finding that next Earth could change everything, not just how we see the universe, but how we see ourselves. To figure out whether an exoplanet could potentially support life, we need to take a close look at its atmosphere, if it even has one, that is. And this is where telescopes like the James Webb Space Telescope, JWST, come into play. Webb's cutting-edge instruments can study the starlight that filters through an exoplanet's atmosphere during a transit. Different chemicals like water vapor, carbon dioxide, methane, and oxygen leave unique fingerprints on the light spectrum, allowing us to see what the atmosphere is made of. Now, here's where it gets really exciting. If we were to find an atmosphere rich in oxygen, especially alongside other gases in a state of chemical imbalance, it could be a strong sign of life, what scientists call biosignatures. While we haven't found definitive biosignatures yet, we're making progress every day. Telescopes like JWST are turning what once felt like science fiction into real, measurable data. They're helping us get closer to answering one of the biggest questions out there: is there life beyond Earth? When we gaze at the stars, we're not just looking at distant points of light. We're catching glimpses of countless worlds, each one unique, brimming with possibilities. As we push the boundaries of exploration, we're reminded that our small blue planet is part of something far greater. Let's hold on to what makes Earth so precious, while daring to dream about what lies beyond. If you enjoyed this journey through the cosmos, don't forget to give this video a like and hit that subscribe button. By doing so, you'll join us on more amazing adventures, exploring the wonders of space, science, and beyond. And don't forget to click the notification bell so you never miss a new upload. We'd also love to hear your thoughts. What excites you most about the discovery of exoplanets? Let us know in the comments below. Stay curious, keep looking up at the stars, and we'll see you in the next video.